Welcome to Study Loop.
So let's look at the first case. On page 198 of the textbook, we will find an explanation. That's actually the curve which shows the gravitational field inside of the Earth or any kind of planet with a constant uniform density. And what do we have is basically, so this is the gravitational field, the strength of it. This is the distance. And up to a radius r, which is the radius of the planet. So let's make also here a little sketch. R, the force, the gravitational force increases. And when we look at the scale, basically, we have the scale. The human is standing on it. And then we have the gravitational force pulling down. And we have the opposite force, Fs, the supporting force, acting in the opposite direction. And Fs determines our weight. So if we look now in this graph, what happens at r half is, we can go up here, we can look, well, Fg on the surface, as we have at the radius r. If we go to r half, the force actually halves. So we have a Fg surface half. And therefore, if this force is only half as big, also supporting force at r half is only the gravitational force at the surface half from the same. So our weight is only half as big. What is the different situation when we have a planet which is shrinking? So we have a planet with mass m and a radius r. And then this changes actually, and we are always measuring at the surface. Same situation as before. And this changes to a planet with the same mass, but only, this is actually not readable, r half in radius. And we're still standing on the surface. The thing what changes is we can directly look at the gravitational force, which in the end over the supporting force determines our weight. In this case, gonna be, we have the same mass. We have our mass, which we want to actually measure, g over, let's make this red, this is what we want to measure, over r half, which basically means, in this case, since the planet, the mass of the planet actually stays the same, the gravitational force doesn't decrease, but it increases to 4 times, this is squared, 4 times g m over r squared. So basically, if it stays the same, our weight, if just the planet shrinks, is 4 times bigger. Because in the previous one, the effective mass of a planet, when we go inside of the planet will be smaller. An explanation for this